All right, today we're going to be talking about Chapter 7, Lesson 4. This is dealing with scale drawings. So, first of all, scale drawings are models. They can be used to represent objects that are too large or small to draw or build. The scale gives the ratio from the drawing or model to the actual object. Now, when we are dealing with scale, generally what we see is we see it as scale, and then we see the word to, or we can do scale, and we can see a colon, or what we could do is actually see scale as a fraction. So, for example here, example 1, it says find the distance on a map. So this is Lincoln County here. And it says find the distance below between Merrill, which is right here, and Irma, which is right here. Now I know Merrill kind of extends all the way in this area, but Merrill specifically is located right here on this point, is where it is requiring us to say that this is where Merrill is. Now, it says to use a ruler to measure. So what we're going to do is we are going to use a ruler to figure out how far these objects are away from each other. So, we're on centimeter paper. So I'm going to use centimeter. The reason why, never mind, it's on centimeter. Yep. So I'm going to go ahead and use my ruler here. And from Merrill to Irma, it looks like it's about 6.5 centimeters. So going up, here's Irma right here at 6.5 centimeters. Now the scale shows that it's 1 centimeter for 2 miles. So I'm going to write that down here. 1 centimeter for 2 miles. Now, because we have 6.5 centimeters between Merrill, which is right here, and Irma, again, which is up here, what I'm going to do is I'm going to multiply this by the scale factor. So this scale right here, 1 centimeter for every 2 miles, means that if I have 6.5 centimeters, I'm going to multiply that by 2 miles for every 1 centimeter. And what this means is I have 6.5 times 2. So I'm going to do 6.5 times 2, which happens to be 13 miles. These centimeter units are going to cancel each other out because I have a centimeter unit in the numerator and a centimeter unit in the denominator. So just like numbers, they can simplify. So all that remains is miles. 6.5 times 2 is 13. So according to this map, Merrill is 13 miles away from Irma. Now, sometimes we actually won't have any kind of picture, but let's look here at example 2. It says an artist is painting a large mural of flowers on the side of a school. If she uses a scale factor of 4 inches equals 1 inch, which means that this is the scale, or this is the model here, and this is the actual thing, which means that the mural is going to be 4 times bigger than an actual flower, which makes sense because if we're painting a large mural on the side of a school, we want it to be bigger than what it actually is representing. So it says, how big would a rose bloom be if it is 6.25 inches on the mural? So what we're going to do is we're going to start solving this problem. So 6.25 inches And this is on the mural. Next thing we're going to look at is our scale. So we have 4 inches for the mural for every 1 inch in actuality. So we have the mural in the numerator here, which means that I want to multiply it by 1/4. The reason why is because this has to be 4 times bigger, which means the actual number has to be divided by 4. Now, when we start multiplying fractions, we want to get this to be a mixed or an improper fraction. So if you recall, 6 times 4 is 24, plus the 1, this would be 25/4 times 1/4. Which means this is going to be 25 in the numerator, 16 in the denominator. I want to simplify now. So 16 can go into 25 just once. An envelope full of 9 left over. So this is going to be how big a rose bloom would actually be if it was 6 1/4 inches on the mural. All right, let's look at example 3 then on the back side. Finding a scale factor. Now, important thing to keep in mind here. This is very important. Scale factor has no units. Which means if it has no units, both the scale and actual dimensions must, this is big, must be the same units. Because if they're the same units, then they'll cancel each other out. They will simplify to just no units. For example, if we had, let's say, 30 centimeters to 1 meter. This right here is the smaller of the 2 units, which means I want to get my bigger value to have the same units as my smaller value. So this is going to be 30 centimeters. Right here, 1 meter is 100 centimeters. Now, if you recall from finding the scale earlier, what I want to do is still do the scale to the actual, which right here, the scale is always the first number, and that'd be 30. 100 is always the actual, it's always the second number, and that's 100. And if I go ahead and simplify this, this is going to be 3/10. That right there is the scale factor. So let's go ahead and do example 3. It says find the scale factor of a blueprint if the scale is 1 inch is the same as 36 feet. Now this right here is the smaller of the 2 units. So this is the one I want to keep. This right here is the larger of the 2 units. So this one I want to change to get to be the same as the smaller units. Now, 36 feet is the same as how many inches? Well, we do 36 times 12 because there are 12 inches in each foot. And at 36 feet, I would have to multiply 36 times 12 to figure out the inches in 36 feet. And that happens to be 432. So I'm going to put 432 here again. Now, get rid of those units. So I can say either 1 to 432, or I can also write it as 1 colon 432. right, well, that is the end of lesson 4. If you have any questions, please let me know.